Hello students, this is a lecture on electric charge and an introduction to Coulomb's law and the equation. In the next mini lecture after this, I am going to go over the actual equation with a document camera and go over some problems. So what are electric charges? Electric charges are first observed as static electricity. Have you ever walked across a room and went to greet someone and basically zapped them? That's because when you walked over the room, possibly on a shag carpet or a carpet or something like that, you picked up electrons. And then when you touched the other person, those electrons got transferred. Similar to a glass rod or an amber rod, it's rubbing against some sort of material like fur, and it will basically acquire charges, and then through that you can also attract small objects. So here is an example of the two different types of charges. So you can have two types of electric charge, one that's a positive charge or one that's a negative charge. If you have two like charges, they're going to repel, or they're going to move away from one another. And if you have opposite charges like a positive and negative, they're going to attract or move towards one another. You could see in term A, there's a negative rod charge and a negative rod, and you can see if you were going to move that towards one another, this rod is going to move away from it. As in B, you have a negative charged rod and a positive charged rod, and they're going to move towards one another. So all electrons have the same charge, as well as a charge on the proton. So electrons and protons basically have the same magnitude or number of amount of charge. So either an electron or a proton has a charge of 1.6 times 10 to the 19 coulombs. I know it's a very small number, but it's kind of cool. So the electrons are in an atom, basically are in different shells, level shells, and they spin around the nucleus. And the protons are found within the nucleus. So what happens if you look at this? You have an amber rod that's rubbed with for some fur. First, in the diagram A, you're basically by themselves. Then as you rub the fur and the rod against the fur, it collects charges. And so now the rod has picked up negative charges, and because the electrons left the fur, they're left with a positive charge. So what we want to learn is the total charge, okay, of some systems. So universally, the total electric charge is conserved, which means it cannot change. But an atom that has lost an electron is now positively charged, and an atom that's gained an electron is now negatively charged. Some materials can be polarized. That means they're aligned up. This means that their atoms rotate in response to the external charge. This is how a charged object can attract a neutral one. So here you have a positive one, and you can see whatever this is material-wise, you see the negative and the positive of each individual cell or atom is now lined up, so all the negatives are going towards the positive external charge. I'm going to talk a little bit about insulators and conductors, but I'll talk more about that when we actually do some circuits in the lab. So a conductor is a material that basically can conduct. So wires, anything metal, the electricity can flow, electrons can flow through that. An insulator is something that's going to insulate it. So most insulators are non-metals, and basically where electrons will have a harder time moving from atom to atom. I want to get to, so to learn a little bit more about that, I wanted to jump to Coulomb's law. So Coulomb's law, basically, if you can have a positive and negative charge and they're going to attract one another or move towards one another, then there has to be some sort of forces involved. And that's where Coulomb's law comes in. So basically it states that you can calculate the force between 2 point charges. So whether you had a electron and a proton or two different electrons, you will be able to find the force that is pulling them or repelling them. And what's interesting here is the Coulomb also had a constant. It's one of the first constants that you'll find, but the K constant, which they also refer to the Coulomb's law constant, is 8.99 times 10 to the 9 Newton times meter squared divided by Coulomb squared. So it's basically the force that you can find that's connecting these charges, whether it's attracting the charges or repelling them. And this is the one we're going to concentrate on calculating. So I wanted to give you some examples here. So here's two forces in A, have two charges, okay? So one of the things not only do you have to find out the actual physical number in the calculations, but you really need to also watch whether it's a positive or a negative. So right here, Q1 represents charge 1, and it's a positive charge. Q2 is a positive charge. So like charges repel. So that's where you're seeing the force now is denoted with an arrow. So the force direction is going in the opposite for each of these charges. And you can see there's also a distance between the two charges. I'll talk to you a little bit more about that, but as the distance decreases, so does the force. So here's a different example. In B, you have charge 1 that's positive and charge 2 that's negative. Now you can see the forces are going towards one another, or they're attracting towards each other. Another interesting thing that you need to pay attention to here is this force is called force 1, 2. That means that's the force from charge 1 going to 2. This force is the force on charge 2 going to 1. So this is important when you're trying to find the total forces on one charge. Okay? So if I involve one more charge, if there's 3 charges, then you have to find the forces for each of those charges. Just one more example here, and that is if one was negative, charge 1 is negative, charge 2 is negative, again, they're also going to repel. So whether they're both charges are both positive, as in A, or if they're both negative, as in C, they're going to move away from one another. And the one time when they are a positive and a negative charge, they're going to go towards one another. And this is what I meant before. So if there's multiple charges, the forces are added by superposition, or you basically want to concentrate on that one force. So if you look at this picture A, you have 1, 2, 3, 4 charges. And A is denoting all the forces that are coming onto charge 1. And this is how you would find out. So you want to find out the total forces on charge 1. You would have, is this a plus and a plus? So you would have charge, force from charge 2 and charge 1, and that's the arrow showing this one. You have charge 3 with charge 1, so you have to find out those are 2 positives. So again, they're going to repel. So the force from charge 3 on 1 is called F1,3. And then you have one more, charge 4, looking at charge 1. Again, these are both positive, so the force is going to go in the opposite direction, and that's why you have this. The other thing I want to bring up here is that this is charge 1. So the only forces you're looking at is all the forces that apply to charge 1. That's why you have F1,2, F1,3, and F1,4. So Coulomb's law is stated in terms of point charges, but it's also valid for spherical or circular charges that measure from the center. This is as far as I want to go in the chapter right now. I want to go over the actual equation of Coulomb's law and do some practice problems in the next lecture. See you then.